Okay, so welcome back, and we are still on we're still on exam 2 from the 2016 fall semester, and we're on question number 2. It says, what are the electron geometry and the molecule shape of axion chloride, axion dichloride? So, as we mentioned before, the way to approach this kind of problem is like we need to draw out the Lewis structure first. And the first step of drawing Lewis structure is count how many valence electrons do we have. So oxygen has 8 numbers of electrons, and each oxygen has 7, so it's going to be a 7 times 2, and that equals to how many? 14 plus 8, it's 22 electrons. And then we put down the molecule with the most electropositive molecule in the middle, which is oxygen, and then we just connect, and we just put down the other molecules, the other atoms, and try to make a connection, and then so that consumes 4 electrons for forming the bonds, and now we have 18 electrons left, and we just put them around the outside molecule first, and that takes 12 electrons, and we have 6 electrons left, and we just put them in the middle to satisfy the axiom. And I think the formal charge looks pretty good. It's going to be a 7 minus 7, which gives us a 0. And this is also a 7 minus 7, which is also another 0. And for the central atom, it's going to be an 8 minus 8. It's also going to be a 0. So it's pretty much the perfect Lewis structure already. And all we need to do is to find out what's the let's for easing our process, let's find out what's the electron geometry first. So as you can see, there's two electron groups in this particular around the central atom. So the numbers of, according to this almighty picture we have, it says there are 2 numbers of electron groups. So it's going to be called no, I'm sorry, there's a 1, 2, 3, 4, 5 numbers of, so 5 electrons groups around the central atom. So it's going to be a trigonal bipyramid. Not so sure if this color demonstrates well through the videos. It looks very close to white from my perspective. So it's called a trigonal bipyramid. And then, so that's the electron geometry. And the first, so we can actually already eliminate the answer to C already, but let's just let's just go through the question to the end. So as you can see, 3 out of 5 of these 3 out of 5 of the electron groups are lone pair electrons. So there's actually two. Can actually switch color by itself for some reason, but it looks so cool. I have no idea. Never mind. So, so there are actually 2 like non-lone pair. I think I spelled lone wrong, but that's okay. Lone pair groups. So that's actually I think by definition this is a x x5 e2, no, e3. That means e. And if we check the handout we had, so it should be a linear. It should be a linear molecule, which is kind of makes sense. Like the chlorine atoms, let's use green for chlorine atoms because they are somewhat green, and axiom for like orange. No, I mean you have to make it green first. Yeah, cool. And let's make an orange in the middle, and let's connect them together. So it is actually a linear atom, so the answer is C for question number 2. And let's end here. If I can click on the button correctly.